Welcome back. Today we're going over integration by substitution, better known or more commonly known as U-sub. So, U-substitution is probably the most common integration technique out there. But before we get into it, let's go ahead and talk about what is integration. So, integration, I like to think of it as just the opposite or the reverse of a derivative. Okay, and to visualize that a little bit, we're going to just say um, d dx of x cubed is, as we know, is just 3x squared. So if we take the derivative of x cubed, we get here. So this is derivative. And if we were to go backwards, this would be integration. So the integral of 3x squared dx would just be 3x cubed over 3. So that will cross off plus c. Because remember, it's an indefinite integral. So this just equals x cubed plus a constant. So as you can see, x cubed derivative is 3x squared. And then 3x squared integral is x cubed plus c. All right. So what happens when there is a function within a function? So up until now, we have done just basic integration, as we just did right here. But what if the integrand, or what the function inside the integral, is more complex? For example, there's a function within a function. What do? That is when we go to U-substitution. So notice this example. We have a function x squared plus 1 within a total function, 2x times x squared plus 1 to the fifth dx. So for u sub, you're going to set u equal to the inner function, usually. Now, I say usually, and I'll circle back to it in a second, but usually because this is not 100% of the time. So, but for now, we're gonna focus on just the inner function. All right, once you have u, you're going to take the derivative of u and set that equal to whatever the derivative of u is times dx. And then we're going to rearrange to, to get dx. So this will end up just being, I'm going to say question mark over du. All right, and then we're going to substitute these variables back into the actual equation. So what this looks like, I'm going to solve it here. So we have, I'm going to set u equal to the inner function. So this would be our inner function. So it would be x squared plus 1. And before you do u substitution, you can always try solving this with a normal integral. But once you find that it'll be almost impossible to solve, use u substitution. All right, so we have our u is equal to x squared plus 1. Our du is just the derivative of that. So this would just be equal to 2x dx. And then rearrange for dx. So we're going to move dx to one side, and then we're going to have du over 2x. And my apologies, this should be du over whatever we get. All right, so now I'm going to plug all of this back into the original equation. So we're going to get 2x times u to the fifth, and dx is just du over 2x. Now notice how we have the two x's cancel out, and that is very important because if they did not cancel out, we would have both an x and the u variable, which we have not learned how to solve yet. So it is very important that when you do U substitution, you your other variables all cancel out, and the only thing that is left is U. That is why I wrote usually up here, is because sometimes the inner function is not the function that needs to be U. Sometimes there's multiple functions and you got to pick and choose the correct one. But in this case, we did the inner function. So to simplify this a little bit, we have integral of U to the fifth du, and this is something we can solve. So this just ends up being U to the 6 over 6 plus C. Now, let's go ahead and go back to our original variables, which is x. We don't want to leave it like this because our question asks for x. So plugging your variables back in, we get that this is equal to x squared plus 1 to the 6th over 6 plus c. And there you go. And that is how you take a very difficult equation, an integral, and simplify it using U substitution. Let's go on and do a trig example. So we have the integral of x cosine x squared dx. I'm actually going to choose my u to be x for a moment for this problem, but before I do, I want to show you what would happen if I chose cosine x squared, or if I chose just x squared. If I chose u to be x squared, my du would be 2x dx, and then my dx would be 2x over du. I'm so sorry. It'll be du over 2x. So then we have x cosine u du over 2x. So we see our x's cancel out, which is great. I'm going to take this 1/2 and put it out in front because constants can go in front of the or outside of the integral. So all this will leave us is cosine u du. And then we know that from our rules that the integral of cosine is just sine. So this will be 1/2 sine u plus c. Putting our u back in, we get 1/2 sine of x squared plus c. So notice how we solved that with where our u is our x squared. I'm going to try it now where our u is just x. So if we chose u to be x, this right here, then our du is just going to be 1 dx, and our dx is just going to be our du. So if we were to do it like this, we would get integral of u cosine u squared du. And notice how this doesn't actually help us in any way because we still have a u times a u. So it still makes it's still doable, but it just makes it's kind of a useless step. So this is why picking the proper u is important. Let's go ahead and do one more problem. So we have integral of x over x squared plus 4 dx. I'm going to set my u equal to x squared plus 4, just to make it a bit simpler. And don't be afraid to guess what the u is, work it out, and then go back. U substitution, once you have it down, is pretty quick. So we have du is equal to 2x dx. Dx is equal to du over 2x. Now let's plug everything back in. So we have x over u times du over 2x. You cancel out, bring the 1/2 in front, so we're left to 1/2 integral 1 over u du. And if you look at your formula sheet, the integral of 1 over u is just ln u. So we have 1/2 ln u plus c. Now let's plug it back And for u, we have 1/2 ln of x squared plus 4 plus c. And there you go. So to recall for U-substitution, remember when using U-sub, there should not be any other variables when you are in the U-sub world. It should only be U. If there are other variables, you did something wrong. You need to go back and pick a different U. Or that problem is not a U-substitution problem. Don't forget your dx when you're writing out your integrals. So in this portion right here and this portion right here. Don't forget your plus C's. This is something that is said in almost every single calculus class, but yet it is still the number one missed thing on every single exam. And don't forget to change back to x at the end because the answer does not care about u, it cares about x. And there you go. Hopefully that helps on U-substitution, and I'll see you next time.